It is estimated that 20% of small businesses fail in the first year. A business advisory group takes a random sample of 500 new businesses that started in January 2018. An analyst employed by the group suggests the use of a binomial distribution is appropriate in this case. So we could say that we have a binomial and 500 businesses and a probability of them failing of 0.2. What's the probability at most 120 of the businesses fail in the first year? Would be the probability of x being less than or equal to 120. So we'll go for a discrete, and we're after a binomial CDF going from 0 to 120 with 500 trials and a probability of success of 0.2, and that's 0.9877. What is the approximate distribution of the sample proportion of small businesses that fail by the end of the first year in the sample? Justify your answer. Well, the justification is just that there's 500 businesses, so we have a large n, or certainly large enough to use a normal approximation. So we've got p hat would follow a normal distribution with sample proportion 0.2, and the variance here would be 0.2 times 0.8 divided by 500. So we get 0.2 times 0.8 over 500 is 0.00032. So 0.2, 0.00032. So what is the probability that the sample proportion of businesses that fail by the end of the year is less than 0.18? So we're going for a normal CDF here with a lower at negative infinity and an upper of 0.18 with sigma as 0.00032. No, it'll be the square root of that because that was the variance. Square root of 0.00032, and the mu is 0.2. 0.1318. So that was the probability of p hat being less than 0.18. By January 2019, 90 of the 500 new businesses had failed. Calculate a 95% confidence interval. So first of all, let's work out what 90 out of 500 is. That's 0.18. Okay, make a note that that's the 90 out of 500. Okay, and we also need the 95% Z score. So go for an inverse normal, go center, want the center to be 0.95, and that's 1.96. So that's Z95, 1.96. So we would have 0.18 take away 1.96 times the square root of 0.18 times 1 take away 0.18, which is 0.82, over 500, and then 0.18 plus 1.96 times the same thing. So 0.18 take away 1.96 times the square root of 0.18 times 0.82 over 500 gives me 0.146. And then we want the same thing, but with a plus. 0.213. Okay. The Business Advisory Group believe that the proportion of new businesses that fail within a year can be reduced by providing financial advice. They took another random sample of 500 businesses that started in January 2019 and provided them with regular financial advice. In this random sample, at the end of the year, 80 businesses have failed. Calculate the sample proportion, so that's just 80 over 500, which is 0.16. And the margin of error for the 95%. Well, 95% Z we know is the 1.96. And this time this will be 0.16 times 0.84 over 500. So 1.96 times 0.16 times 0.84 over 500, which is 0.0321. Calculate a 95% confidence interval for the proportion of businesses that failed. What do you conclude regarding the value of the financial advice provided to the new businesses? Okay, so a 95% confidence interval, so that's going to be 0.16 take away the 0.0321, 0.16 add 0.0321. I might use a few more decimal places. So 0.16 take away all of that is 0.128. And if we have a plus instead, we get 0.192. So what could we conclude? Well, if we look at the other confidence interval that we had, 0.146, which was 0.146 and 0.213, you can see there's considerable overlap. So I think it would be difficult for us to draw a conclusion. Not only that, but the 0.16 is well within the original confidence interval that we had. So I don't think that we could really justify that the business advice has really made any difference. Okay, if the sample were reduced, what would the effect on the confidence interval be? Well, it will make it wider. So it's definitely going to make it wider because basically it's the 500 in the denominator that's being reduced, and therefore the margin of error becomes larger, and therefore the confidence interval becomes larger. State two assumptions that the analyst made in recommending the use of binomial model for this case and discuss whether they are valid. Well, they're sort of saying that all businesses are equally likely to fail. And that's probably untrue. Businesses in different sectors at different times are likely to have very different probabilities of succeeding or failing. And also assuming independence, and that's not true. The business world is an interconnected world, and so related businesses may fail for the same reasons or different reasons. And what about businesses that interact? One business might be a customer of another business, and if one of them goes out of fails, then the business who's relying on the custom may also suffer. So independence is also not really valid.